Hi, this notebook demonstrates four unsupervised techniques: clustering, k-means, hierarchical clustering, DB-scan, and dimensionality reductions such as PCA, SNE. I'll quickly explain purpose, show short demos, and interpret the outputs. Environment and imports. I start by importing numpy, pandas, matplotlib, cbon, and suppresses warnings to keep plots clean. The plot.rc params and sns.setStyle just make visuals easier to read. Key point here. Let's understand what is random state. It is used to mention reproducibility. Here, let's first discuss about data preparation. Here I create synthetic data with make classification to illustrate pre-processing and pipeline steps. We split into train and test and note the number of features, which are 20. This helps show dimensionality later. Synthetic data is used to control for the ground and work as a ground truth label for evaluation. K-means partitions data around centroids by minimizing within clusters within cluster variance. We generate blobs with 4 centers and run k-means in clusters as 4. The code prints inertia, sum of squared distance to centroids, the Shilhorte score, and Dives Bolden score. All are cluster quality metrics. Interpretation. A higher a higher Shilhorte close to 1 indicates well separated cluster. Lower Davis Bolden is better. Inertia is useful relatively. Elbow method. Then we visualize true labels versus predicted clusters and plot centroid as red mark. Point to mismatch, point to mismatches and cluster shapes. Here let's understand what is elbow. We compute inertia for k value from 1 to 10. The elbow suggests a good k when inertia improves. Slow, slows, improvement slows. Here, in the given plot, we can understand k means cluster plots, true labels versus k means predictions, centroid marks and elbow points. Centroids, predicts, shield order near 0.5 is decent. Near 1, excellent. Negative means poor clustering. Hierarchical clustering. Agglomerative clustering merges sample bottom up. We fit agglomerative clustering and print the Shilhorte score for evaluation. Here, I also show a dendrogram built for linkage matrix. Here, we can see how we are cutting the dendrogram at a height gives clusters, and you can see visually choose k value. Here, the computational cost and when hierarchical is preferable. Small datasets, whenever we have small datasets and it is interpretable, then we have to use this. DB scan. DB scan groups points by density and identifies noise. We generate make underscore moons non-linear shapes and run db scan with eps 0.3 mini samples 5. The code prints the number of clusters and number of noise points. If more than one cluster, it prints shilhote. Here, we compare k-means versus dbscan on the same data. K-means forces spherical clusters and fails on moons. dbscan captures shapes and marks noise. dbscan is great for arbitrary shaped clusters and outliers. Show f's and min samples carefully. K-distance are point and plots are very important to observe. Take your time. PCA. PCA is a linear method that projects data to orthogonal components comparing maximal variance. We use the digits dataset, high dimensional 64 features, and standardized before PCA. We pass n components as 0.95 variance. Scikit-learn returns the number of components needed to keep 95% variance. Here in the notebook prints reduced shape and explained variance ratio, which should be 0.95, and n components shows how many components that required. Interpretation. If n components is small relative to original features, PCA gives a compact representation. The cumulative explained variance plot shows diminishing returns for more components. PCA is good for linear structure and can be used before clustering to reduce noise and speed up algorithms. TSNE. TSNE is a nonlinear manifold manifold learner optimized for visualization 2D and 3D. We run TSNE on a subset first 1000 samples for speed and plot the two-dimensional embedding colored by digits. Here we import caveats to emphasize. TSNE is a computationally expensive, non-deterministic. Results vary unless you fix random state and other parameters. And it's not transform. You can't project new unseen samples. With the fit TSNE. Here, in the scatter, TSNE is scatter colored by labels. Here, TSNE is great for visualization, but computationally expensive, non-deterministic, can't be used for new dataset. For the best practices, always split data before pre-processing, use cross-validation for model evaluation, monitor for overfit and underfit, document hyperparameters and experiments, start simple, then add complexity. In summary, use k-means for spherical clusters, hierarchical for interpretability, dbscan for density outliers. Let's understand the main concepts in unsupervised learning, clustering and dimensional reductions. K means hierarchical clustering, dbscan. When should you apply these techniques? Apply when you need to improve model performance, reduce dimensionality, or extract meaningful patterns from data. What are common challenges? Common challenges include overfitting, computational complexity, hyperparameter tuning, and interpretation of results. These are some practice exercises you can work on.